Hi, my name is Jennifer Zimmerman, and today I'm going to go ahead and show you how to solve for equations missing one variable. Now we're going to be looking at equations that are linear, quadratic, and exponential. But first, I think we need to go ahead and go over what a linear equation is. A linear equation has a standard formula as y equals mx plus b. This is going to be the standard one that you'll use a lot. But for right now, this is what we need to look at right here, the mx. The x is the missing variable in this equation. Both m and b are just constants of the equation. M is the slope, and x is to the first power in all linear equations. So an example of this could possibly be, we can just make one up real quick. Okay, 9 equals 2x minus 1. 9 will be your y, your 2x is going to be your mx, and then you have your negative 1 as your constant b. So how we go about solving this, usually I would say draw a line from your equal sign all the way down to separate both sides of the equation there. One side I would put a number sign, so this is where I want all of my numbers to be at. And this side I'm going to go ahead and put where I want my x's. So I need just 2x on this side by itself, and then from there we would solve for x. Okay, so let's go ahead and drop these down and write them in. 9 on one side, 2x minus 1 on the other side. Now, in order to get this number to the other side, we need to use a property known as the addition property. What this tells me is I take the opposite of that number and add it to both sides. So once I'm looking at negative 1, take the opposite, which would be positive 1, and add positive 1 to both sides. This is going to cancel out your negative 1, leaving you with just 2x on this side. Now we go to the other and finish this equation. 9 plus 1, 10. So once we're looking at this, I still do not have x by itself. So we need to go ahead and figure out something that we can multiply to both sides, known as the multiplication property, which will give me just x by itself. Because this is a 2, we can multiply it by 1/2. This will cancel out both 2's, leaving your answer just being x. So then you take your 1/2, multiply it to the other side. 1/2 times 10, half of 10 is 5. So x in this equation equals 5. Now to go ahead and check our work, we need to put x back in right here as a 5. So let's write it out to the side. 9 equals 2x minus 1. Now x equals 5. So we're going to write 9 equals 2, parentheses 5 minus x. So then we start to solve. 2 times 5 is 10. You drop your minus 1, drop your equals 9, and then you have 10 minus 1 equals 9, so that means they check properly. So our answer is 5 in this equation. Okay. So that is what a linear equation and how to solve for that one. Now we're going to go ahead and look at quadratic equations. So a quadratic equation is ax squared plus bx plus c. This is the standard way to write a quadratic equation. Now we're going to look at actually solving for the x's if you see them. So what we need to do is we need to factor this. And what we might come out with once in a while, there are usually 2 answers to each one of these. So let's go ahead and take one for an example now. Let's go with x squared minus 9 plus 9x plus 14. Okay, so we need to look at these like this. So this is where we use FOIL, and we're going to go actually backwards with using FOIL. We're going to factor these out. So we know there's going to be 2 linear equations multiplied. And since this is right here is just x squared, we know that x multiplied together gives you x squared, so we just start those off right there. Now, we don't know the signs yet because both of the signs are different, and we don't know what these numbers are right here. And that's what we're going to look at solving next, are those numbers right there. So we're going to put a big X out to the side and draw 2 lines. These right here are going to signify the missing numbers in our factor. So on the top we're going to put C, and on the bottom we're going to put our B. Our C is right at the end with no letter, so that is 14. Our B is right here with the X, so that is going to be negative 9. So let's fill these in. So what I'm looking for with these 2 numbers is a number that is multiplied together to give me 14, and a number that is added together to give me negative 9. In order to solve for that, I need to go ahead and find what numbers multiply together to make 14. So some of them are going to be 1 times 14 as well as 2 times 7. And that would be the only ones, because now you just look at the reverse of those. So then we know which ones multiply to 14, so we solve those problems. Now we need to find some that add up to negative 9. 1 plus 14 is 15, so that does not count. But 2 plus 7 equals 9. So then the question is how do I get those negative? If I'm going to add them together, 2 plus 7 equals 9. If I need that negative, I can just distribute negatives throughout the entire addition. So then that'll give me negative 2 and negative 7 added together equal negative 9. So then we come in here and we write that in. So these are going to be our factors. Now we need to go ahead and take another step and solve for x. So this all equals 0 right here, no matter what. So then we put each linear equal to 0. So x minus 2 equals 0, as well as x minus 7 equals 0. So when we draw our line again, to change sides, what side we want x, which side we want numbers. Put the x, put the numbers, so x minus 2, and I have 0 over here. Do the same thing to this side. This is where I want my numbers, x minus 7. Do the addition property, which would be adding 2 to the equation on this side, canceling out my 2's and adding my 2 over here, leaving me with x equals 2. This one, I look at the negative 7, so I have to add a positive 7 because it is the opposite. Those cancel out. This ends up being 0 plus 7. So this ends up showing me x equals 7. So that is the answer for both of those. So either one will equal 0 in that case. So that is our way to solve, one way to solve our quadratic equations. Another way is using the quadratic formula. And we're going to go ahead and use the same problem just because we're going to see if our answers equal the same. So we ended up having what? X equals 2 and 7 being our answers. So let's use the quadratic formula. We'll put formula. Okay. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. If you cannot factor or you have a hard time trying to do the factors going backwards from FOIL, then you can go ahead and use it. You should always get the same answers regardless of which method you use. So you need to go ahead and use the best one that suits you. So we're going to go ahead and finish in this formula right here. B tells me negative 9 plus or minus, because that's going to give me the two different variables right there. B squared is negative 9 squared minus 4, then A was 1, and C is 14. Okay. All over 2 times 1. Okay, so we have negative 9, which ends up being 9, plus or minus the square root of 81, minus 14 times 4. 14 times 4. We'll just do this real quick, just to show some people still have to use multiplication from time to time. It doesn't always help. Okay, 56. Square root of that, all over 2. Okay, so then I'm going to go ahead and continue. Everyone have their formula written because I'm erasing it now. And that's going to give me 9 plus or minus the square root of 25, actually, all over 2. So now we look at the square root of 25 is 5. So I have 9 plus or minus 5 all over 2. So this tells me 9 plus 5 is going to be one of my answers. So let's write this over here. 9 plus 5 divided by 2, as well as 9 minus 5 divided by 2. Okay? 9 plus 5, we are looking at 14. 14 divided by 2 is 7, as well as 9 minus 5 is 4. 4 over 2 is 2. Now these answers both match for this problem. So it's up to you on how you decide you want to go ahead and choose to solve it. The formula or factoring. Okay. The last one we're going to go ahead and look at real quick is the exponential ones. And there's some special about the exponentials. They have a set base, and the variable itself is the exponent. That's why these are so special. So A is going to always be the same. X is going to be what you're looking for. So an example could be 3 to the x power equals 27. Now we know with exponents that anything is the same number multiplied itself until you get your answer. So we need to look at how many times do we multiply 3 to get 27. So if we start going 3 times 3 is 9, that's not 27, so let's add another 3 to that one. 9 times 3 is 27. So how many times did I multiply 3? Well, I did 1, 2, 3 times. So that tells me my x equals 3. Now if we go ahead and look at another one that have same bases, these are a little more fun to do. We can look at one going 4 2x minus 1 equals 4 of x plus 3. Okay, because both of these have the same base, we can go ahead and just ignore those and just go straight to the actual equations, which, if you notice, are linear equations. So now we go back to drawing our line again. I would choose a side which has the most x's, so I would make this side x and this side my numbers. So I went back to my t-chart, drop everything below in it again, and now we start to move stuff around. Now I need numbers over here, not x's, so how do I get rid of an x? I subtract an x out of it. I do the same thing to the other side. Cancels out my x's, leaving me with x minus 1, and this side is just 3. So now I need to come look at this. I have x minus 1. I don't want the 1 on that side. I need to move it over. So back to my addition property. Let's go ahead and add those in there. Cancels it. 1's out. X equals 4. So that is how to solve for the same base ones, where the 4's have the 4's. Now the last one I want to show you is a tricky one, but it's the same concept as equal bases, except for now you're going to be looking at 4, let's make these not so hard, equals, and let's do this one as 8, and let's do 2x. Okay, so now both of these numbers are different. So how do we look at them? Well, what do they have in common? They have 2's in common, right? So how many 2's do you multiply together to get 4? Well, it's 2 squared, right? So that equals 4 right there. And now we just put our x on the outside. And now we go to this one, 8. Okay, well, they have 2's in common. How many 2's multiply together to get 8? Well, you're looking at 2 times 2 is 4, times 2 is 8. So this is 1, 2, 3. And then that one goes in parentheses. We can erase that. And now you're looking at 2x. Now we need to go ahead and actually distribute this 2 to everything in the linear equation on top, and go ahead and do the same thing to the other side and then solve for that. So you would be looking at 2x minus 8 equals 6x. Now we're back to looking at just a regular linear equation again. So draw our line. This side has more x's, so I'm going with that side. So I have 2x minus 8 equals 6x. Well, I want the 2x's to go away. Minus 2x minus 2x leaves me with negative 8 equals 4x. Now I have to use my multiplication property. Multiply this by 1/4, the reciprocal of 4, and do the same thing over here. Negative 8 times 1/4 is going to equal x. So we would be looking at negative 2 equals x. And you can go ahead and go back and check these to make sure they're equal, but I'm going to go ahead and let it go at that because that's something you could always do on your spare time. Okay, so from there I would be giving these students their assignments to work on. More than likely it would be a lengthy one, only because there's a lot that they can practice, and once they get used to them, they get to do them fairly quickly. And then from there I would be able to help anyone who would ask for it. All right, thank you.